233. Oh, okay. I think we are ready to start. Okay. Hello, everyone. My name is Joey. I work at Pendo. I'm a senior backend engineer at Pendo, so I do some of the stuff down in nitty gritty. But my presentation here today is going to be about RESTful APIs. And yeah, we'll start. There we go. I was told to make you guys scan this. Cool. I guess I'll continue. So the agenda today, I don't think I'll take the whole hour. So and the rest of it, we can do like an AMA, I suppose. But what I have planned for this is I'll explain what is an API, and then I'll explain what is REST, and then kind of merge the two and explain what is a RESTful API. I don't know why that's there. But at the end, I'll do a quick little full stack demo, mostly focusing on the back end, but how the front end interacts with the back end. So yeah. So what does API stand for? It stands for Application Programming Interface. The most important part of those three words is probably the interface part. That kind of allows software to communicate with each other. What it does, it provides some sort of standardized interface that allows one machine to interact with another. And they don't necessarily need to know how each other does anything. It's just one central point of contact, and give it some input, you receive some expected output. So here's an analogy. Say you have a customer and you're at a restaurant, okay? What a restaurant does is orders food from a waiter. The waiter then tells the chef to cook something, right? The chef goes into the kitchen fridge to get some ingredients to make their dishes. And then once they make their dishes, they give it back to the waiter. And then the waiter gives it back to the customer, and hopefully they're happy, right? So this is a kitchen, right? This is how a kitchen works. There's more to it, obviously, but I'm not going to go into that. So the analogy in terms of tech, say you're the front end. So here's Pendo's UI. It has a bunch of numbers, a bunch of graphs and stuff. That obviously comes from data, right? So we request data from the API. The API itself can be, it doesn't have to necessarily look like this, but this is the most common way it looks like for web development. So this is under the HTTP protocol, and it just looks like a path, and then we have some verbs here. And this API talks to the backend. So the chef is the backend. Whenever you go to a restaurant, you don't really see the chef, right? It just happens behind a wall through a window where where the waiter gets their dishes. So the API tells the backend to do some stuff. And then the kitchen fridge is kind of like your database. It's where you store things. And then when the backend gets ingredients or its data from the database, it does some stuff, business logic, maybe ask another API, say like, I don't know, Meta wants to ask Google Maps for metadata around some location. And then does stuff, returns it back through the API, and then eventually back to the client, so the website, and displays the data however it needs to. Any questions around that while I drink water? Awkward. Okay. And all of that is kind of behind the scenes in what we call the cloud. The cloud is basically anything that a front end would talk to nowadays. back in my day, we used to have self-hosted servers in our own company buildings. Now companies will outsource all that cloud development to other companies. Those companies being AWS, Google, and Microsoft with their cloud provider or cloud offerings respectively. Here at Pendo, we use Google though. Yeah. So what is REST? Um, REST is some acronym that stands for representational state transfer. I can never explain what that means. But it's basically an architectural style that kind of defines a set of constraints and principles for designing networked applications. And REST in of itself is a very specific way of implementing APIs, kind of like how I mentioned. They typically look like that image right there in the middle. And that in of itself is actually a contract between the front end and the back end. So it's kind of the front end saying, I'm expecting these APIs to look like this and expecting a specific input, and I'm expecting a specific output. Um, and yeah, REST is, or AT, it's generally implemented for HTTP protocol. That's pretty much what most web applications use. There are some exceptions for other things, but this is for the most part what you will find if you go to like Facebook. That's what they're doing here. And it's defined by some authority called RFC. It's a really long document of words and text and rules. Basically, the guidelines though. And the goal of REST is to make APIs easier to work with and understand. Most public APIs will follow these kind of principles. So say like your Twitters or your Metas, they'll hopefully follow RESTful APIs. But at the end of the day, you can do God knows who knows what with your APIs and have funny behaviors. But that makes people angry, especially if it's open to the public and everybody's using it. So some principles of REST, client-server architecture. So this kind of decouples the front end and the back end from each other, and that way they can be developed on and developed on independently. So if you guys have used Git, obviously you would make your commits and put out merges, and then hopefully that or put out changes, and that gets merged into your code base. Well, if everything is in a singular repo, that makes things kind of messy. And having both, even having one front end or back end can make it kind of messy, but you kind of have to deal with it. But if you have everything in your back end and there's changes across things, you have these things called merge conflicts, right? And it just creates an overall bad experience. So that's kind of one of the reasons why we have client-server architecture separating. I think Google does not do that though. Statelessness. So each request kind of contains all the information that the server needs to fulfill it. Generally, you want that so that the server doesn't store any ephemeral data. So basically sessions about between requests that just creates a lot of load on the back end to kind of think about, oh, this request did that, and then this other request did something else. How do these relate? That's generally not fun to deal with. So we don't do that. But sometimes you do because you need to. Um, and also it creates a standardized interface. So kind of like what I was mentioning before with those kind of URLs and paths. Those paths are called resource-based URIs. It's just kind of this way of considering resources. And I'll explain what a resource is later. We also use proper use of HTTP verbs, things like get, post, delete, and then also using standard HTTP responses, so your codes. I'll go into that later. And also servers return representations of resources. So if you say, I want an ingredient, I get back some metadata about that ingredient and nothing else, right? So resources. So resources can be thought of as nouns. So kind of back to that analogy of a restaurant. A restaurant can have an inventory of ingredients and dishes and menus and staff, etc. And those resources, we can, just from that one sentence, we can gather there could be inventory, ingredients, a dish, menu, staff, an employee. A staff is a group of employees, or an inventory is a group of ingredients, but dishes are comprised of multiple ingredients, stuff like that. I don't think I wrote a slide for that or how to write schemas for that. But I did for one. So HTTP verbs. Each resource, you generally want to have different kinds of actions associated with it. So say you want to be able to create, read, or update, or follow the CRUD pattern. And that means when you translate those two into HTTP verbs, you get a read or a get, and that's a read. So you retrieve information. You don't write anything. And then for post, you create. This creates whatever resource or item you're trying to create. And then a put is for an update. This updates the data with some fields. A put is technically supposed to input or update the whole object. There is another verb called patch, which is intended for partial updates. Some people don't do it, some people do. It's all about how you want to make people happy. But for the most part, people just kind of do put and call it a day. And then there's obviously delete. This deletes your data. And there are a few more out there, but these are the main ones that you'll ever really implement or see. So we kind of want to mash up together the resources and verbs and create an API. So say we have an API for ingredients. A get for that would be, what could look like something like this. So kind of like that picture from before, we have our verb, and then some path, and then to our resource ingredient. So to me, what this endpoint looks like or says to me is that it fetches a list of ingredients, right? It's just a general endpoint. And then for a post, you have this one as well. It looks almost the same, but with a post, and that would create an ingredient. And then a get, after that general looking endpoint, we have this little syntax here with a colon. That to me says I'm going to provide some ID looking thing. So 1, 2, 3, ABC would be like an ID for an ingredient. And then that would return to me the specific ingredient as opposed to like a list of ingredients. A put, kind of like that previously mentioned endpoint, we want to update a specific ingredient. And then a delete, there's supposed to be a colon here, but this would be deleting a specific ingredient. So what is an ingredient for us? Here's some pseudocode schema that I have for an ingredient. So we have some fields like an ID, that is a string. That could be whatever ID you want. Or best practice, you use a database auto-generated ID. So have the database create your IDs for you. That kind of helps create or ensures that things are unique and you don't have overlaps. We have some other metadata. So like say I want to know when it was created and when it was updated. So integers would be timestamps in Unix numbers. Yeah. And then other things that we actually care about. So a name would be a string, count integer, cost per pound would be a float or a number, depending on what language you're using. So I think I mentioned HTTP codes from before. This kind of, whenever you make a request, you're expecting some sort of response, right? But sometimes that response fails, whether it's your fault or the server's fault or other kinds of communications. So here's a list of a bunch of them. I'm not going to go through those, but TLDR, we have HTTP status codes. The 100 series are informational. I've honestly never used those before. I don't know what they mean. 200 series, those are the ones you want. So 200 OK is probably the most common one. That means that you did something right and you got something correctly or got something back correctly. There's others like 201 means created, 202 means accepted, etc. The rest I've never used before myself. 300, it's kind of like your redirects. Say you like log in and they want to redirect you to another page. That's what these codes are for. And then the more fun ones are 400 and 500. So 400 means that you messed up. 500 means the server messed up. So here's my explain like I'm 5. So 1xx, you kind of hold on. I'll give you more information. 2xx is, yay, here you go. Here's your stuff that you requested. 400 series is you need to do better. And then 500 means I need to do better as the server. And the reason why these are important is if you get 200, you just display the data. If you get a 400, you probably want to communicate to the user that something broke. Maybe you should try again. Maybe you should try it differently, stuff like that. Or the 500 server's broken, so wait until it gets fixed or tell somebody that it needs to get fixed. So next, I'll go over what some of these APIs would look like, right? So if we want to create an ingredient, say we hit this endpoint from your application, and we want to give it a payload. So we want to give it some information on how to create this object here. So say I just want to create some carrots. There's 24 of them, and they cost $2 per pound. And then what I would want as a response is a 201 created. So that means it was created successfully. And then its response. So notice how there's a difference in some of the fields. So ID got created, and then the created and updated at got set. So those would be fields that the backend would be setting for me and that I shouldn't have to deal with myself. So next, say in the case like something broke, I want to create an ingredient, but I give it the wrong input. So in this previous one, this was a JSON object. In the next one right here, I'm giving it a string, but it encapsulates the JSON object. Well, a string is not what the API is expecting, so it would return a 400 bad request, and hopefully you would know to fix that. And then say there's like another scenario that maybe you messed up. You give it some invalid type. So before I defined my name as a string, well, if I give it a number, it's not going to like that, right? It won't know what to do, especially if you're using Java, where type languages will cry. So that would return the 422 unprocessable entity. To be honest, 400 bad requests versus 422. Some people are lazy, some people don't care. You can just send back a 400 if something messes up. But if you want to be really specific, you can do 422. But definitions are always up in the air and they kind of change. So up to you. Whatever makes sense. And now say once you created your ingredient, you want to fetch it back. So here's that endpoint, the resource, and then the ID from the previously created one. You wouldn't put a payload for any get endpoints. That's generally a big no-no. You can, but I don't want you to. And that will return you 200 OK and that object that we created before. And getting a list ingredients, well, it's pretty much the same, but without that ID and no payload, returns us a list. And we want to update an ingredient. So kind of like that post request from before, we have the put endpoint, but we have an ID here because we want to update a specific one. And in the payload, I just want to decrement the count. So before it was 24, it's now 23 because I used one for my carrot soup. So you update it and it returns. And two things change here. So obviously the count, but also the updated at time because we made a request. That kind of helps you know when objects are touched and if something, say in like production, something goes wrong, well, you know somebody updated at this time and you can narrow down issues and stuff like that. So generally good practice. Normally I would have like user keys, like who updated, who created it and who updated at this time. So you have some sort of trail. And I think security really likes that. And if you don't have it, they'll yell at you. And deleting ingredient. Oh, there's supposed to be an ID after this slash. So pretend there is. So obviously you're deleting a specific ingredient. There's no payload, but you also don't get a response because that object doesn't exist anymore. So where do all the ingredients go when you make these requests? They go into a database. But if I know this is a hackathon and putting it in a JSON file or something, writing to it is sufficient. But you get brownie points if you use the database, in my opinion. So you do you. My favorite database to use for hacky stuff is MongoDB. It's easy to connect, stuff like that. So I think I have a demo. Any other questions though, actually? You. Social implications? Um, I don't know if I have a good answer that for that. I guess like from a technical standpoint, you're basically putting all of your data into another company, right? And they're hosting it for you. Obviously, they'll encrypt it for you, and technically they can't see into it, but they technically still have the data. And there's a lot of policies, especially in the EU. I know for Pendo, we have to deal with a lot of privacy laws in the EU. So because we have to do that, and we're also a global company, we implement all of the policies for the US customers as well. So our customers get the ability to delete their data if they need to, stuff like that. Kind of like how if you want to go into Facebook and you want to delete your account, do you trust Meta to delete your account all the way from Amazon's database in Ohio? Um, yeah. Does that answer your question at all? No? Okay. Cool. Uh, Wrong. Okay. So here's an API in action. Um, I'll look at some code. So this is here on the right is a Node.js server. So I'm using Express. I'm connecting to MongoDB, and it's all in JavaScript. So here I connect to my database. This is where I'm storing my data. Here's my schema that I've told the database to follow for this particular ingredient. And then here I have a bunch of my API routes defined, right? So this one's my post for creating. Here's an ingredient for getting them all, and etc. So say we take a look at the post here. This function here takes in this another function called a closure in JavaScript. And what this does is it handles the request. You would generally have a lot more logic, but this one's really simple. All it does is takes the input, doesn't really change anything. But I do set the created at and updated at times. And then I just stick it in the database and then return some with a status and then the response itself. The other ones are pretty similar to this. So when I have this set up, I can go to my front end. It's pretty not in the best shape, but say I create a new ingredient. So let's call it carrot. And then there's 24 of them, and it costs $1.99 per pound. So the reason why I have this thing here is open up on the right. This is called Chrome DevTools. All your browsers will have some sort of DevTools here. And I'm in the network tab and I'm seeing these requests. So this one right here that I have opened up here is the post request that I just created. And inside of here is the payload. So we have account, name, price per pound, other fields that I forgot to remove. And then what's returned is this object here. So here it has the time set, the backend set, also the name and the price per pound, and the auto-created ID. And then to get back a list, I use the get endpoint. So API ingredient, and that returns to me a list of ingredients. So this one's an array right here, and I display it right here. And I can also edit. So say it's decremented, save that. Here's my put. And it's reflecting that I decremented it, and here's a return. And then it's changed back here too. And then I can also delete. The way this looks like in the front end, I decided to use view for that. And I'm not going to show you all the boilerplate, but here's my ingredients component. So I have a bunch of form fields for taking the input, and then this uses the model pattern. So it just adds the values to an object automatically. Somewhere down here, I would make something called an HTTP request. So here's one. I'm using the library called Axios, and then here's a get function for a get request, and it's hitting this API endpoint. And this is what I would use for fetching that list of ingredients. And this is the one that I use for creating an ingredient. So yeah, any questions? You?
Accessing the public APIs.
So with public APIs, a lot of the times if you like sign up and do stuff, you'll get something called an API key, right? That's what you would use to kind of basically authenticate yourself to these APIs. You can stick it in your code, but generally you would want to have that set as like an environment variable in your code, or not in your code, but in your environment, in the terminal. But I guess like a lot of these APIs cost money. So there's also that implication. I'm sure there's like free tiers. But do you have any like specific questions on how to? Because there's okay, because like there's plenty of like all kinds of APIs. There's like the Google Maps. There's Twitter. Actually, I'm not sure if Twitter's API is public anymore. Um, but yeah, there's all kinds of different kinds of APIs. I think Open APIs, AI API, Open AI's API is also public, so you can use that. Yeah. Did I answer your question at all?
Think that- So if you were using a different RESTful API, just when you made the API call, you would put like that URL.
Oh, yeah. So depending on how do you want to like design your API or use other APIs, your front end can call directly to some other API. Or if you're calling a bunch of APIs, you wouldn't want all that logic to be handled in the front end. Say you want to call Google Maps and then you want to call Uber's API and etc. Well, having the front end handle all the API keys is not great. So you want to do that in the back end. So you want to create your own API and have your API call these other APIs. Yeah. That way that your front end application has one API to deal with. And then your API is kind of your bridge to others. Cool. Any other questions? Okay, well, that's all I had.